Let us discuss about the brief classification of the elements into S block, P block, D block and F block elements. That is based on the number of electrons which are going to enter into different orbitals, right? So based on this one, they are going to classify like this. In that first one, we are going to discuss about the S block elements. What do you mean by this S block elements? So these are the very general concept to understand the periodic table. So the elements whose atom receive the last electron in S orbital of their outermost energy shell. That is nothing but the electron, the last electron which enters into that S orbital, we are going to call the S block elements. The elements which ends with the S orbital, so they are going to call as the S block elements. We can take the example of this sodium, right? You know the sodium metal. Sodium is the atomic number will be 11. So configuration 1s2, 2s2. 2p6, 3s1, right? The last electron of the sodium metal which enters into this S orbital, right? So that's why this element belongs to S block elements like this. And general electronic configuration of this S block elements is ns1 to 2. N means principal quantum number. N may be any numbers. 1 to 7 like this. 1, 2, 3 like this. S means S orbital and it contains the 1 R2. If it is containing NS1, if it is containing the electronic configuration as NS1, they are going to call as the alkali metals. They are going to call as the alkali metals or group 1 metals. If configuration is as NS2, means last 2 electrons enters into S orbital, that is 2, that is going to call as alkaline earth metals, or we are going to call as the group 2 elements like this. When you see this chart of this one, the group 1 elements you are going to see here, and also group 2 elements also you are going to see here. And general electronic configuration will be, so generally we are going to write as NS1 to 2. And these are the metals like very soft metals having the low melting point and boiling point, and also they are highly electropositive. So you know that metals means they are always highly electropositive. Suppose now I am going to consider this sodium metal only. So because of the outermost electron is only one in the S orbital, right? We are going to remove the one electron from this S orbital. It is very easy. You are going to remove this S electron. That is very easy. After losing the electron, then we are going to form the positive. That is called Na+. That's why these metals, they are highly electropositive. Like this, magnesium also will be there. Like this. So boiling point and highly electropositive. And showing the oxidation state as a +1. So now you can see here, this is +1 oxidation state, right? Na+1. So showing the +1 oxidation state, they are going to these sodium element which comes under the alkali metals. And those elements show the +2 oxidation state. This is +1 oxidation state, +2 oxidation state. They are going to call as the alkaline earth metals. I am going to give example. Magnesium 2+. This magnesium 2+ means the oxidation state of magnesium is +2. When the +2 will be there, then those elements which comes under the alkaline earth metals. And usually S block elements are ionic compound. Ionic compounds means the compounds which will be going to form by ions. I am going to give the regularly example as the NaCl, right? This is called NaCl. How this salt which is going to form here? Because of the ions attraction. This is called Na+ and this is called Cl-. We are mentioned the charges, right? So this is a force of electrostatic force of attraction between this positive charge and negative charge. The bond becomes very strong. So that is we are going to call as the ionic bond. However, lithium and beryllium they form the covalent compounds. Covalent means the mutual sharing will takes place. But almost all the elements which belongs to this S block elements, they are going to form the ionic compounds. One more example I can take here. That is called magnesium chloride. So this is also salt. This is also salt. So this is also formed by the ionic compound. So like this. These metals comes here, but one thing is exemption is hydrogen. Hydrogen is not a metal, it is gas. So hydrogen is gas, but even though their outermost electron will be NS1, that is called 1s1, right? That's why that hydrogen gas also belongs to this S block elements. Let's discuss about the second one, that is called the P block elements. as usual the same definition. The elements whose atoms receive the last electron in their p orbitals of their outermost shell, that we are going to call as the p block elements. If I am going to take an example of the oxygen, simple oxygen. Oxygen atomic number will be 8, right? I am going to fill the electrons 1s2, 2s2, 2p4, right? Because 2 plus 2 4, 4 plus 4 8. I mean according to the definition, the elements whose atoms receive the last electron in their p orbital, right? So these are the last electrons which are going to fill in the p orbitals, right? So that's why these oxygen belongs to the p block elements. And what are those elements? The group 13 to group 18 belongs to the p block elements. As you can see this image, so group 3 to group 18 elements, they are belongs to the p block elements. And the general electronic configuration of this p block elements will be ns2 np1 to 6. ns2 means the s orbital completely must be filled, right? So you can see here, this is an s orbital, right? So s orbital has completely filled here, right? S orbital ns2, 2s2 has completely filled, and remaining whatever the outermost electrons which are next entered into the p orbital. So general electronic configuration of this p block elements is ns2 np1 to 6. And the elements who have completely filled electrons, that is ns2 np6, means they are completely filled electrons. They are going to call as the completely filled electrons. Those elements we are also called as the noble gases. Noble gases. You can see the periodic table chart. Whenever you see that always the group 18 noble gases which are always placed at the right side of the periodic table, means why they are placed right side means according to filling the electrons in the periodic table horizontal wise, the last completely electrons in the respective orbitals which are going to be filled at the last RHS side, right hand side, so they are going to call as the noble gases. You can give the example for this one: argon, krypton, xenon, radon. So these are all called as the noble gases because they are completely the outermost electrons, they are going to go completely filled here. That's why they are going to call as the noble gases, and they are also less reactive. They are less reactive because of the completely filled electrons. So and also you can see one more interesting, there is the helium. Helium will be atomic number will be 2 and its configuration will be 1s2 only. But even though there will be no electron, there is no electrons in the p orbitals, even though they are going to place this helium into this noble gas elements, right? So this is also showing the properties of the noble gases, but the electrons they are not entered into the p orbitals even though. And they show variable oxidation state. They are going to show some variable oxidation state. Why they are going to show variable oxidation state? Because of this configuration you can see here, right? np1 to 6 means the electrons which enters into the p orbitals, there will be up to 6 electrons can place in the p orbitals, right? That's why they are going to show the different variable oxidation state. You can see here oxygen containing the maximum 4 electrons in the outermost orbital, right? If we take nitrogen 2p5 like this, oxygen, nitrogen like this will be there. So that's why they are going to show the variable oxidation state because of this configuration. And they are going to form usually ionic compounds as well as the covalent compounds. Covalent compounds, you know this one, that is called chlorine gas. They form the mutual sharing pair of electrons between these two chlorine atoms. They form the covalent compounds. I can give one more example. There is also water. Water is also an example for the covalent compounds. This oxygen and this chlorine comes under the p block elements. And also they form the ionic compounds. How means? That is example for this one is sodium nitrate. So this is an example of this p block elements which shows the ionic compound, that is called nitrogen atom. This nitrogen atom, so which will be present in this compound sodium nitrate. Ionic means charge separation, Na plus NO3 minus. So that's why p block elements shows the ionic as well as the covalent compounds. And most of them are non-metals. In this p block elements, they are non-metals. You can take the oxygen, nitrogen, these are chlorine, these are the gases, right? Almost maximum gases will be there, but and they are not the metals. They are non-metals. And most of them are highly electronegative. They are highly electronegative. If you take this nitrogen, oxygen, fluorine, like this the elements comes. So the electronegative means they have the tendency to attract the bond pair of electrons towards them, right? That is called electronegative. And in the periodic table, the fluorine is containing the more electronegative, and its value will be around 4.0. 4.0. It is having the fluorine is having the 4.0. Its electronegativity value will be 4. This will be the highest in the periodic table, as well as in the p block elements. The fluorine is containing the higher electronegativity. So this is a general characteristics about the p block elements. Next one, let us discuss about the d block elements. So if the last electron which enters into the d orbital in their penultimate shell, that is called n-1 d orbital. So what do you mean by this penultimate shell? So let us discuss here. In an atom, you know that one, the outermost shell will be there. I mean, the nucleus will be there and shells will be there. Which is the nearest to the nucleus, that is called the inner electrons, which are outside. I mean, outside that orbit. I mean, they are far away from the nucleus. That shell we are going to call as the valence shell, and the electrons which fill into that shell, they are going to call as the valence shell electron. And here in this d block elements, so before the valency of the metals, they are going to write the inner orbitals, that is called the n-1 d. So that's why this is going to call as the penultimate shell. So before the valency of the electrons, we are going to write this orbital, that is called the penultimate shell. And this is a general electronic configuration of this d block elements will be n-1 d 1 to 10 and ns 1 to 2. I mean, the electrons which enters into this orbitals containing 1 to 10 electrons, and s orbitals containing the 1 to 2 electrons. And here the group 3 to group 12 belongs to the d block elements. Yes, you are going to see this periodic table. The compounds which the elements which comes under group 3 to group 12 elements, they are going to call as the d block elements. And also this is called the central part of the periodic table. This is the central part of the periodic table. And those elements which lies between the s and p block elements. So that's why they are going to call as the transition elements. Whatever the elements which comes under group 3 to group 12, they are nothing but so when you see the entire periodic table, first group 1, group 2 elements, first there comes here, that is called s block elements, and after that one, middle part will come the d block elements, after that p block elements will come, right? So in between the s block elements and p block elements, what are the elements placed? They are going to called as the d block elements, are also called as the transition elements. And they exhibit variable oxidation state, and they are also colored. You know that one, they are going to exhibit the variable oxidation state because of this configuration. Because you are going to enter the electron in this orbital 1 to 10. You can place 1, 2, 3 like this. It depends upon their atomic number. And also they are colored compound. You know that one. So that is example iron. That is also nickel. Those comes under this. Because of this variable oxidation state, they are also showing some colored compounds. And usually, so these as the name indicates, transition metals means they are metals. There is no non-metals matter here. They are purely metals, and when they are called metals, they must be containing the high melting point. You can take the example of the tungsten, right? So tungsten will be higher in the melting point. And they are good conductors of heat and electricity. So the best example is copper, yes, right? Copper. They are good conductors of heat and electricity. Example, silver, gold and copper. This comes here. And they form alloys. Alloys means mixtures of metals. We are going to call as the alloys. So the example we can take here, brass. Brass is a mixture of the elements that is called copper and zinc element. Let's discuss about the last element, that is called the f block elements. If the last electron enters into an f orbital in their anti-penultimate shell, that is n-2 f orbital. So I mean, you know that penultimate shell is nothing but the shell which is under the valency shell, right? That is called penultimate shell. The shell which internal to the penultimate shell, that is we are going to call the anti-penultimate shell. Here this is called anti-penultimate shell. If n-1 d, that is called penultimate shell. If ns or np, that is called outermost shell. So beside this outermost shell, that we are going to write this is called penultimate as well as the anti-penultimate shell. And containing two series, the f block elements containing mainly two series, that is called lanthanide series and actinide series, and the general electronic configuration will be like this: n-2 f 1 to 14, n-1 d 0 to 1, and s2. This is a general electronic configuration. So here the lanthanide series containing, that is called 4F series. It starts from cesium to lutetium, and actinide is a 5F series, starts from thorium to lawrencium, and they are going to call as the rare earth elements because they are usually exist in the earth crust. That is called rare earth elements. And they are metals, right? Metals means they are having the high melting points, variable oxidation state. Because of this configuration, they show variable oxidation state, and due to this variable oxidation state, they are going to call as the colored compounds. And most of the elements in actinoids are radioactive elements. Most of the elements which belongs to this actinide series, they are going to call as the radioactive elements. Radioactive elements is nothing but the man-made elements or synthetic elements. Generally, they are not going to be found in the nature. The first element, that is called radium. The element that is called radium, which is going to be, this is called man-made element or synthetic element, which is going to be found out by the Madam Curie. So this is called first man-made element, that is called radium. So those are called as the radioactive elements. And you can see the overall configuration, that is general electronic configuration of these blocks. S block is noble gas NS12, P block noble gas NS2, NP126, D block noble gas N-1, D1 to 10, NS1 to 2, and F block noble gas N-2F 1 to 14, N-1, D0 to 1, NS2. This year, that is PUC. So only the S block elements will come here. The remaining P block, D block and F block will be coming to the higher studies.